is, if two lines have the same x-intercept but different y-intercepts, how many solutions might there be? The easiest way to answer this is to draw a sketch to try and get our heads around what's happening here. So maybe I have a blue line and it has this x-intercept. And then maybe I have a red line and it has the same x-intercept, but it has a different y-intercept. Like maybe the y-intercept of the red line is here. Maybe it's actually down here, right? So there's possibilities for the red line. Maybe it crosses it like this. Maybe it crosses it like this. But it cannot lie on top of the blue line because it says specifically that it has a different y-intercept. So once you draw the picture, you can kind of see that they cannot be the same line. They must be different lines, but they do connect at one point, and that one point is the x-intercept that they share. So they're only going to intersect in one place. And so there's only going to be one solution. If I told you, or if I didn't tell you that they had different y-intercepts, then maybe they could actually lie on top of each other and be the same line. And then you could have infinite solutions. But you have to have at least one. And it's not possible for them to have zero solution because if they share the x-intercept, then that's a solution for sure. In part B, it says that the two lines have the same slope. How many solutions might there be? And the students were asking, wait, do they have the same intercept? And it does not say if they have the same intercept. It just says that they have the same slope. So we have a few possibilities. If we have a line like this and a parallel line like this, then there would be zero solutions. But if we had this as our original line and then same slope, but it's actually the same line, then you're going to have infinite solutions. So there's actually two possibilities in this case. You have to be careful. If 6 comma negative 2 is a solution to the system, what must P and Q be? So by default, if you have coordinates, this is x and this is y. If it's a solution to the system, what it's testing to see if you understand is that you can put these guys into both equations and they should work. So what that means is we can substitute 6 in for x and negative 2 in for y. And we're going to get a different system. 6 plus 2p is 2q, and 6 minus 2q is equal to negative 2p. And then we can solve. And probably the easiest way to solve this, possibly by elimination, but be careful because these guys don't match up with these guys. So what I can do is I can rearrange maybe the top equation. Maybe I'll rearrange it to move this one over there. So 6 minus 2q, and then the 2p will move over here. Is equal to negative 2p. So here's my two equations right here. And I suppose I can subtract them. And I think we're going to run into a problem here, actually. So the problem is that these are the same equation. So now if they are the same equation, then they are equivalent. So these are equivalent. And then that means that P and Q can be anything. Sorry. So it doesn't matter what P and Q are. But if this was a better thought out question, you would only get one solution for P and Q. So what this also demonstrates, though, is that if you end up with an equivalent system or equivalent equations in both cases, then it cannot be solved, and you're going to end up with like a 0 equals 0 case. So yeah. So I have $1.75 in nickels and quarters and 15 coins in total. How many of each coin do I have? So we're going to let an equal number of nickels and Q equal number of quarters. And I know that I need two equations. So the first equation is pretty easy because I know that if I add these together, I'm going to get 15 coins. That's how many I have in total. The harder one is to figure out how the value of those coins relates. So if you take 5 cents, which is the value of a nickel, times your number of nickels, plus 25 cents times the quarters, then you're going to get $1.75. So those are your two equations. The easiest way to solve this is probably to multiply this by 0.05, or my preference is negative 0.05. So negative 0.05 n minus 0.05 q is equal to 15 times 0.05, and it'll be negative 0.75. So then we can add these equations together. And then I can divide both sides by 0.2. I'm getting q equals 5, and they have to add up to 15. So then that means my nickels must be 10. So we're solving a system of equations. They've only given us one equation, and they've told us to do it by substitution. And they're asking us to choose which substitution could be made. So the students were able to say, okay, so it looks like in all these cases, they have isolated for x. So even though it's possible that you could isolate for y, they're going to isolate for x. So what we can do is we can try to do what they did and see if our answer shows up here. So oftentimes what students might do is they might say, okay, well, I actually want to kill off all my fractions first. So maybe I'll multiply everything by 12, and that should kill off the 4 and the 3, but I also have to do it over here. Okay? So then the 12 divided by 4 turns into 3, and 12 divided by 3 turns into 4. So we're going to be left with 3x minus 4y is equal to 24. And again, we're trying to solve for x. Okay? So we're going to move the 4y over the other side. So 4y plus 24. And then we're going to divide everything by 3. Now this is the part where you actually might say, wait a second, I think I see something showing up here. Now it doesn't look exactly the same as this one over here, but it looks maybe kind of similar, right? So some of them end up with a 1/3 in the bottom, like this one here and this one here. So what we could do is we could pull out that 1/3 and it would look the same. Yeah, like this is equivalent to that one. I know that most of you would have reduced that 24 divided by 3 and then left this at 4/3 y, which is fine if you wanted to solve it, but you just have to recognize that this expression is the same as this expression. And as a matter of fact, D is the answer in this case. That's your substitution right here. And that's not easy to see when they write expressions differently than you. Furthermore, you might see questions where they actually give you both equations, like maybe they gave you this equation and they also gave you this equation. And so maybe then they would ask you which substitution is correct, and instead of showing you x isolated, they might actually take this thing and plug it in here for x. So then you might see something awful like this: 1/3 4y plus 24 plus y is equal to 1. So their entire equation has y's in it, and the reason is because they took this and plugged in for this. But if you were here at the last virtual class, you would remember that there are many ways to do it. So what if your way doesn't match with their way, and you see all these options and none of them look like what you would have done? Well, remember that you can always solve the system. You can find out what x is. You can find out what y is. And if you're too lazy to do it, then do it in Desmos. And then you could solve this equation and see if the answer matches. And if the answer matches, then it is quite possible that that is going to be a legitimate substitution. And if it doesn't match, then it's not legitimate. So it says, in solving this system by elimination, an equation which arises could be which one? Now, in some of these cases, they have eliminated A. Like in these two cases, they've chosen to eliminate A. And in these two cases, they've chosen to eliminate B, and that's why you're left with an A. So you could try and solve it both ways by elimination and see which ones come out true. But I actually chose to do it a little bit differently. I chose to try and hack the question a bit. So I was kind of curious as to what would happen if I just solved this. And I was too lazy to solve it, so I put it into Desmos. And let me quickly show you what that looked like. So in Desmos, if I type this in, it looks like the solution is 4, -1. So I have solved this And I found that 4 comma negative 1 is my solution. So there's A and there's B. So instead of actually having to solve this by elimination, I can just ask myself, okay, well, what does B come out to in these cases? So B is 7 if I solve this. That doesn't look right. B is -7, I guess. -7. Yeah, B is -7 in this case, which is not right either. In this case, I'm seeing that A is 21/5. That doesn't seem right. And over here, A is 4. So in this case, I happen to have hit the jackpot because this A matches the correct A, the A that I know is correct. And that's why I know that this is the right one, even without having to solve it. So do use that graphing calculator to your advantage if you can. What restrictions must be in place for this system to have one solution, no solutions, or infinite solutions? So just as a review, in order for it to have one solution, these guys must intersect at one point. That means that they have to have different slopes, and then they will have one solution. If there's no solutions, that means that they are parallel, or they have the same slope, but different y-intercepts. That means that they're not the same line. If they're infinite solutions, that means that they have the same slope and the same y-intercept. But if we look at the way that they're arranged right now, not only is it a problem how many letters are in here, but it's also a problem because it's not in a format where we can read the slope and read the y-intercept. We need to write this into y equals mx plus b. If we do that, then we'll be able to look at the slope and the intercept, see if they match, right? So we're going to start there. So first, I'm going to take this first equation, and I'm going to move the ax to the other side. So by is equal to negative ax plus 1. And then I'll divide by b to try and get the y by itself. So negative a over bx plus 1 over b is that equation. What about this equation here? So I'll move the cx over, or maybe I'll move the dy over. So cx is equal to dy. And then I can divide by d to try and figure out what that is. So y is equal to c over d x plus, well, nothing, I guess. I'm just going to put a 0 there as a placeholder for that, the sake of argument. And I'm just going to erase this to make it cleaner. So we have rearranged these now into y equals mx plus b form, which is really good because now we can decide whether the slopes match or not. So if we want it to have one solution, then the slopes better be different. So the slopes are here, this one and this one. Because we don't have any letters or rather numbers for this, then all we can say is that this better not be the same as this. If they're not the same, then we have our answer. This is the restriction that will allow it to have different slopes or one solution. If you want it to have no solutions, they have to be the same slope but different y-intercepts. Now, if you look at these y-intercepts here, you have a y-intercept of 1 over b, and you have a y-intercept of 0. Those are never going to be the same. This is interesting because you can't ever choose a value of b to make this 0. Now you might say, well, let's let b be 0. You can't because you're dividing by 0. That's not the same thing. So as a matter of fact, you can already see from here that these intercepts are not the same, and they never will be. So we don't even have to worry about that. All we have to say is that these slopes have to be the same. And the y-intercepts are never going to be the same. That gets really interesting for part C, because if you want to have infinite solutions, you have to have the same slope and the same y-intercept. We can set the same slope, but if I say that it's not possible for these y-intercepts to be the same, then you would say that this is actually impossible, right? Now, in some of the examples you see, you may see, for example, that this isn't 0. Maybe you see the letter P, right? And if you see the letter P, then it is possible for these guys to be the same. So you could say that these guys are not the same. You could set a restriction saying that these guys are the same. So long as you have this sort of unknown piece, then you could try and figure out a way to make those equal, right? But because in this special case it happens to be 0, we can just nail a number to it and say that this is impossible.